Welcome, welcome everybody. In this opportunity, David Bondurant is an architecture for almost computer architect for almost 50 years. He's also a volunteer in IEEE, and this is a co-host event. I am the LMAG chair of Argentina. Jimmy Solis is the LMAG chair from Panama, Pablo Fossati from Uruguay, Roberto Guerra Chirinos from Peru, Felix Brunet from Puerto Rico and Caribbean, and Teófilo Ramos from Monterrey. And as I told you, this is a co-host event. In this opportunity, David Bondurant is going to take not only about climate change, but he's going to talk about his take on climate change. So David, this is all yours.
Okay, thank you. Okay, so are we seeing this okay then?
Yep.
There you go.
Okay, I'm going to minimize this video over here so that I can actually see the screen. Okay, so my talk today is I'm going to review or summarize the book Unsettled. And while I'm doing that, I'll give you a little bit of my take on climate change. And so you can see the cover of this book, Unsettled, that came out in 2000 and I think 21. So this talk I actually gave to the Pikes Peak Life Member Affinity Group back in, I think it was April of 2022. And then I've given it again several times. And so I've done it in several different forms. And I'll be doing this over in France in September for the France LMAG as well. Anyway, so let's get into this. And I'll tell you a little bit more about myself as we do that. You know, although some on the talk earlier had heard who I was, just a little bit more about me. I'm a retired PE or a professional engineer. I'm from the state of Missouri in the United States, so it's in the central United States. My BS in physics is from a place called Truman State University. And then my electrical engineering degree is from Missouri Science and Technology. Back in 1971, when I graduated, it was called Missouri University at Rolla in Missouri. And then I have an MBA from the University of Phoenix later in my career. And so as Gustavo said, I designed computers for about 10 years in the Twin City area of the United States. I then designed computer chips, the semiconductor versions of computers in the 1980s in Honeywell. And then for the last 30 some years, then I was a marketing manager, specifying, if you will, on marketing and selling new computer memory at companies like Ramtron, Syntec, Freescale, and Everspin. So I'm going to give this talk, I think, a little bit from a marketing perspective. In other words, you know, I'm used to marketing and competing with other, you know, very high-tech companies. And so if you get into the marketing of a complex product like a semiconductor product, which I used to sell, or let's say the environmental movement, then we learn quickly that there are some certain deceptive tactics that are being used, such as FUD or FUD, and lying with statistics. And so FUD, or fear, uncertainty, and doubt, is a propaganda technique used in sales, marketing, public relations, politics, polling, and cults, as they like to say in Wikipedia. And so that's one selling technique that we'll talk about. And you can see that it's in green. And so I'm going to highlight things that I claim to be fear, uncertainty, and doubt throughout the talk with green. And so the other thing is, while I was learning my MBA, one of the things you take is How to Lie with Statistics. And so you can see the cover of the book that I took back in 2003 is when I was in the MBA school. And so what you're learning to do is to, as it says, out double talk your accountant and confuse your opponent. And so during this talk, I'm going to point out the use of these techniques that I've observed in the environmental movement. And the author of Unsettled is going to do an even better job than I do. Now, please feel free to, make comments, turn on your audio and make a comment if you feel like anywhere during the talk. Here's a kind of a quick look at my take on climate change. Mine starts out a little simpler. I don't actually claim to be a climate scientist. And so what I'm going to do is just kind of look at it from a marketing perspective and say, where do I feel like I'm being kind of lied to or at least exaggerated? And so this is NASA's view of climate change all in one view graph. And so you can find this, now it's no longer directly at climate.nasa.gov, but if you go look through their climate story, you can see this view graph. And so what you see there is these 4 natural climate change cycles that go back 400,000 years. And so what you can see there is that the carbon dioxide level in the atmosphere is going up and down based on where we're at in a natural climate change process. And so as you can see, the carbon dioxide level kind of peaks out at about 280 or so ppm at the high temperature portion of the climate change. And then it drops to something like 180 ppm during a glacial period. And so, for example, 20,000 years ago, we were in the major glacial period. And today we're pretty much at the top of the interglacial period or a warming period. And so all this data is coming from ice core samples. They drill down and they capture the ice and they measure the amount of carbon dioxide that was captured. There's kind of no guarantee that it's an exact measurement, but it's is a trend record. And so you can kind of infer the process. And so that's exactly what's going on here. As you can say, carbon dioxide is high, the temperature is high. Carbon dioxide is low, the temperature is cold, on the Earth. And so that's the general conclusion you draw. Well, what has NASA done? They've taken a thing called the Keeling curve, which is a measurement of the actual carbon dioxide in the atmosphere measured over the last 70 years. And they appended that to this curve of proxy data, they call it, coming from the ice core data. And you'll note that they're claiming that atmospheric carbon dioxide has never been higher than it is today, based on this curve. And what I'm saying is that's lying with statistics. There are 2 things wrong with this graph. Number one, you're mixing apples and oranges. Keeling data is measured atmospheric data. The ice core data is proxy data. It's just a trend data that you capture from a proxy like ice. Now, the second thing is you'll note the scale. The scale of this curve is basically 2,000 years per point. And so, I would think that line would be very thin if plotted at 2,000 years per dot, if you will. In other words, you really can't put it all in the same chart. Okay, well, my question is, what happened last time that the climate, the interglacial period was at its high temperature point? And so that was called the Ionian. That occurred 120,000 years ago. And so paleoclimatologists say that the winters were warmer than today. Hardwood forests grew all the way to the Arctic Circle. The poles melted, glaciers melted, the sea level rose 6 to 9 meters. Scandinavia, as you can see in this drawing, was an island. In other words, there was enough water that it basically separated from the continent. And Netherlands was actually underwater. It's below sea level today and was underwater back in that time period. And so that's what the paleoclimatologists say. And so that's, you know, kind of how you might project that climate change would be at the top of an interglacial period, which is where we're at today. And so we're 10,000 years into the next interglacial period. And so why wouldn't we be expecting a warmer climate, a rising sea level, and a lot of things that everybody is claiming is caused by humans? And so my conclusion from all of this is that climate change is in fact happening. We just don't have the data yet to say that the current 400 ppm levels of the carbon dioxide in the atmosphere is the highest ever. In other words, I don't know that you can equate those two. Okay, well, now we're going to talk about the author of Unsettled, the book. His name is Stephen E. Koonin. He has a BS in physics from Caltech, where he studied under Richard Feynman, a famous physicist. And he has a PhD in physics from MIT. He was an assistant professor of physics and the provost of Caltech during the years of 1995 to 2004. He then became chief scientist of British Petroleum, in charge of their technical strategy, including renewable energy, from 2004 to 2009. When he was hired by the US government, the Obama administration basically hired him as Undersecretary of Science in the Department of Energy. So these are the guys that are actually in charge of climate change, research in the United States. And he was recommended by Stephen Chu, who was the Director of Energy, the Secretary of Energy at that time. Since then, he basically was the founding director of NYU's Center of Urban Science and Progress. And he's on a bunch of advisory boards, such as the National Science Foundation, the Department of Defense, and Department of Energy. And he chaired a thing called the Jason Defense Advisory Group. If you haven't heard of that, the Jasons have been around since World War II. They're basically a group of high-level PhDs from around the country who get together and advise the government on various technical issues. And so he's advised that group. So we're going to get now into the book and what does it say? And so the first part of the book is kind of the executive summary. And so let's, you can start reading this, but basically everyone says the climate science is settled, as we're told. And the author of the book basically says, and I've never watched the Princess Bride, but apparently it says, I do not think the science says what you think it says. And so he is saying that the research literature and government reports that he reads say that heat waves are no more common now than in the 1900s. Humans have no detectable impact on hurricanes over the last century. Greenland's ice sheet is not shrinking any more rapidly today than 80 years ago. And the economic impact of human-induced climate change will be minimal through the end of this century. Now, the problem is that's the exact opposite of what we're hearing from the media and from governments around the world. And so he goes on to say that in 2013, he was part of the American Physical Society, which is his professional group's public statement on climate, where he got together with a number of other experts and they wrote this report. And he said, humans exert a growing but physically small warming influence. The magnitude of climate models disagree with and even contradict many observations. The government and UN press releases don't accurately represent the underlying reports. And so their conclusion, this is back in 2013, is the science is insufficient to make useful projections on how climate will change over the coming decades, much less what our actions will be when we do something. And so here's kind of like page 2 of the part 1 on the science. He basically just explains that while in the press everything is black and white, in the reports everything has got a shade of gray. And so you can see that data that is collected can range from very high agreement and robust evidence to very low agreement and very little evidence. And so you can get all kinds of different data. And so he talks about how to deal with all these uncertainties in the data. And so what he has used in this report are the UN IPCC reports, which are the major reports that are issued every so often. And so the most recent one of those, I think, came out about a year ago or so. But this book was written prior to 2021. And so the last report is not covered, but he had all the data from the prior 6 IPCC reports. And then, of course, he was also privy to the national climate assessments, which are 4 US-based climate reports that have been developed. So he claims that the reports contain elementary failures that mislead and misinform readers on important points. And so that's what we're really going to be talking about today. So in chapter 1, we start talking about global warming or climate change as we know it these days. And so this is kind of the #1 chart that everybody likes to show, which is the global temperature. They call it the global temperature anomaly, and the temperature change from 1850 to today. And so as he says in the book, the world is a big place, and it's hard to measure, particularly the 70% of the Earth that's in the ocean. And you can see that this chart shows that the variation of temperature is not a lot more. It's kind of like 1 degree C from 1850 to 2019. And the line with statistics part of this chart is that little chart up at the top. You can see that they show that the global surface temperature from 1850 to 2020 basically varied almost nothing in the chart at the top. So if we blow it up big enough, it looks like it's significant. And so it doesn't make clear that 0.8 degrees is really pretty small relative to the average temperature of 13 degrees C that is kind of the average through that period. He goes on to say that New York City average temperature in a given year can vary by more than 2 degrees from year to year. So in his case, the question is, why worry about an 1/8 of a degree change? My question as an engineer, and I think a scientist, is, were the thermometers really accurate to 0.1 degree from 1850 till today? You'll note that the scale of this data is basically 0.2 per division. And, basically we're seeing data, but it's kind of below the accuracy of the devices in the 1850s. You can't convince me that thermometers all over the world were accurate to much less than or much better than a degree from 1850 till today. And even today, I can't believe that all the thermometers in the world are accurate to the same precision. And so can't believe that this is actually the real data. This is an average. It's a model of all the points that they actually measured, but maybe not all the points in the world. And so, and the other thing that the author points out of this chart is the data is anomalous. And so you can see that the temperature rise is higher from 1910 to 1940. And then it's slower from 1970 to 2020. And it even goes negative from the period of 1940 to 1970. And so if you believe that humans and the pollution is causing it, why did it accelerate faster from 2000 or 1910 to 1940, a period where there were fewer cars on the road? Okay, now the next part of the book basically talks about other examples of climate change. And so the media and the public basically do not know the difference between weather and climate. The UN Meteorological Organization defines climate to be a 30-year average. And so the idea that you say today is the hottest in history, that's weather. Now what you would need to do is look at the averages over a long period of time to determine these kind of things. The climate, and he also points out that climate varies significantly with a lot of other things like latitude, elevation, and proximity to water. And so if you're high altitude, it's cooler. If you're at low altitude, it's warmer. And if you're close to water, it tends to be more stable. The water basically stabilizes the temperatures. And so this chart on the right is basically out of the Washington Post in 2019, and it was entitled "Extreme Climate Change Has Arrived in America." And you can note that all the hot spots are located in New York, Phoenix, and Los Angeles, or places where there's been oil discoveries. And so it's interesting that the climate changes in only local areas rather than the entire world, like it showed before. Hidden in the article that reported this was urban heat effects, changes in air pollution levels, ocean currents, events like the Dust Bowl, and natural climate change wobbles like El Nino could all be playing a role in these variations. And so I would argue that, again, they're lying with statistics. This doesn't show, basically they're saying one thing in the title, but they're hiding the details down in the fine print so that you don't actually read that. The chart also arguably shows the impact of urbanization and local climate or local pollution, not on climate change in general. He goes on to show an example of what's called the heat island effect. And so the heat island effect has, gotten some publicity. You can see that New York City at the top and West Point, which is in, I think in the western part of, or I'm not actually sure which part, but it's 42 miles away from New York City, have 2-degree difference in almost 3-degree difference in average temperature over a period from 1910 through 2020. And so what this is demonstrating is clearly the heat island effect of having a concentration of population, a high amount of concrete and other kinds of material, retaining heat in the New York City area. We get out in the country and we have a 2 or 3 degree difference. And so why is this 0.8 of a degree change in the prior charts talking about global climate change so significant in the face of this kind of difference? His next chart basically talks about the UN definition of climate change. Climate change is attributed directly or indirectly to human activity that alters the composition of the global atmosphere, and which is in addition to climate change variability observed over comparable time period. To me, this whole statement is a legalistic definition that excludes natural climate stage from the discussion. In other words, if they were saying that humans are increasing it beyond what normally would occur in natural climate change, I wouldn't have a problem with it. I think they're trying to define it as only the human portion. And so you can see that the chart of the world shows that that the climate varies over the Earth, and so Earth is warming faster than the sea. Some oceans are warming and others are not. And so we're looking at local climate changes, not the overall global temperature change. And so he would argue that the climate is a lot more complex than a simple temperature number like the 0.8 of a degree temperature rise globally. Okay, the next part, he basically talks about that 70% of ocean and what its effect in the climate. Was there a question? Okay, I'll keep going. So what you can see on the right is a chart of the ocean heat content. And so it shows that the top 300 meters of the ocean are warmed by 300 zetajoules of energy. Now, I don't know what a zetajoule is, but what he points out is that it's a lot of energy. And so the annual amount of human energy use worldwide is 0.6 zetajoules. And so the human energy increases the ocean temperature by about 0.01 degree in that equation. And you can see that the amount of energy or heat in the ocean varies based upon depth. And he says that this is just the result of one report. Other studies have half to a third the magnitude of ocean heat. And he goes into much more detail in the book, and he describes how it's hard to get temperature data from the ocean. And so there's a project called Argo that started in 2000. It's a series of underwater drones around the globe. These things basically drop down to 1K and 2 kilometers depth. They capture the data and then they come to the surface and radio it to a satellite. And so that's how we're gathering data on temperature versus depth at multiple points around the world. But he would point out that we don't have any data below 1K before 2000 is what he would say. And so he also shows the temperature proxy data. And so this is global proxy data. You remember proxy data is coming from other sources, things like tree rings or ice cores. And so you can see that the proxy data shows fairly stable temperature from 500 through 1500, and we see a cooling period, which some people call the Little Ice Age. And so what the climate change sciences have done is add that hockey stick again. They basically stuck the key. Yes, go ahead. Question? Okay. So basically, it's another example of mixing two kinds of data on one chart. Okay, here's the next part, which is kind of reiterating what I had said in my little chart. It shows the surface temperature anomalies going back 500 million years. And so, this is basically, you can see a couple of things. You can see from 20,000 years ago, which was the last ice age, you can see that the global temperature has risen by 5 degrees. And it's actually fairly stable for the last 10,000 years. That's kind of, I would note, the period that most of the humans migrated out of Africa to all parts of the globe. And so, of course, it's good to have 10,000 years of stable temperature. But you can see then the natural climate change cycles that NASA had pointed out. And so you can see that the temperature is going up and down every 120,000 years. And then you can see all these kind of minor variations in climate. And so those are all attributed to changes in distance of the sun from the Earth and changes in the Earth's tilt over time, over the last million years. And so you can see this is a recurring process that has to do with the physics of the universe, if you will. Now, if you go back further in time, what you can see is the Carnivorous period, when no animals and microorganisms were around to consume wood. And so this is the period of time when the temperatures were high on the earth. The world's coal supply was created. Basically, the plants didn't, they just fell on the earth and were compressed underground and became coal. And so he basically just points out that this is natural, the kind of perspective of natural climate change, and that it's more complicated than you might think. And so he just suggests that it's hard to separate human cause from the natural cause. Okay, let's see. I'm just looking at the chat line a little bit. Okay, so the next part is kind of getting into the theory of how climate change works. And so you can see that the Stefan Boltzmann law was discovered in the 1880s, and what it does is define how we calculate this stuff. And so the amount of infrared energy that an object, in this case the Earth, emits increases with its temperature. Yeah, if there's anything there, I didn't get it, but you can see that cooling by infrared radiation increases until it equals the warming, which is the radiation that we're receiving from the sun. And so, but it points out that only about 70% of the energy is absorbed from the sun. The rest is reflected back into space. And so if you've read about this stuff, it's called albedo, Latin for white. And so about 30% is the albedo of the Earth, and it defines the reflectivity of the Earth's surface. And so this concept was first measured by Andre Danian. I think he's a Frenchman. I can't remember for sure. In 1930, and he was using a telescope to measure it. And so he basically compared the bright part of the moon to the dark part of the moon to measure how the reflected light from the Earth. And today, this whole idea of albedo is being measured by satellites constantly. And so we have precise numbers on the reflectivity of the Earth. Now, the concept, of course, of climate change due to human emissions then comes from the fact that the greenhouse gases provide insulation to prevent this infrared radiation, the 70% that radiates from the Earth. And so Earth's average temperature would be about 0 if we didn't have any atmosphere. And it's about 59 degrees today because of it. And so actually we're pretty happy to have greenhouse gases capturing some of the emissions of the Earth. And so this insulation that's occurring is occurring because of water vapor in the atmosphere, carbon dioxide, methane, nitrogen dioxide, and ozone, which intercepts about 83% of the radiated energy. And you can see over on the chart on the right that aerosols generated by humans or by events like volcanic eruptions can actually cool the Earth. And so in this case, if we throw enough dark stuff into the sky, we're actually blocking or making that albedo different and cooling the Earth. And so you can see that Mount Pinatubo, I can't remember where that is, maybe in the Philippines, erupted in 1991, and you can see this large negative spike in the radiation of the Earth that cooled the Earth by 0.6 degrees C for 15 months. And so it says it's not just radiation. There are other effects that affect the radiation into space. He goes on to say that the total absorbed energy by the Earth from the sun is 239 watts per meter squared on Earth. And he claims that the human influence is less than 1% or 2 watts per meter squared. Okay, well, here's the next part. We're basically going systematically through the science of this stuff. And so we talk about the carbon cycle. In other words, how does carbon move from Earth to ocean to plants and animals and to the atmosphere? And so Dr. Charles Keeling has been measuring carbon dioxide levels on Mauna Loa in Hawaii since the 1950s. And so you can see his Keeling curve. And so this is kind of the heart of that, what I would call the exponential growth of carbon dioxide that everybody is showing. And so you can see that what's interesting about this data is, number one, it's increasing. It's increased from 310 to 410 ppm over this period of time. But you can also see within that data a 4 ppm cycle as the plants on the earth grow and die. And so when the plants are around, they're basically absorbing carbon dioxide. When they die, they basically are not. And they also may change the albedo or the reflectivity of the earth at the same time. And so that's kind of a natural cycle you can see in the data. He goes on to kind of explain where the carbon on the earth resides. And so you can see that the majority of this stuff is residing either in the Earth's crust, 1.9 billion gigatons, in the ocean, 40,000 gigatons. The amount of carbon on land and in living things is 2.1 gigatons. Now there's about 50 to 100 gigatons of carbon stored in fossil fuel underground in the earth. And there's about 850 gigatons in the atmosphere. So he would just point out that the atmosphere carbon dioxide is 25% of the land and living things, but it's only about 2% in the oceans. And so the question is, who's affecting the atmosphere the most? The ocean or or humans? Now, he would all agree that greenhouse gas emissions are growing, and he's going to go into, over on the right, you can see kind of the breakdown of the human contribution to greenhouse gases by the different type. And so carbon dioxide being number one, and then the other types. Now, he'll point out that carbon dioxide levels have not always been low. And so if you go back using proxy data again, in history, the Earth frequently had higher levels of carbon dioxide, with plants loving the stuff. They basically grow well. They breathe that stuff. And animal life living in those conditions adapted to the higher levels of carbon dioxide. Now, today's humans begin to become drowsy at about 1,000 ppm, but they survived to more than 2,000 ppm. And so this 400 ppm is not threatening us from a human standpoint. He explains that methane, and then he talks about methane, which is another greenhouse gas emission. It's basically a little more potent, but at lower concentration. And so you can see the different sources of methane getting into the atmosphere. And so it's from all different sources. Okay, so we're kind of coming to the end of this chapter 3. And so what they're starting to do is project variations in the carbon dioxide emissions based on various models. And so the biggest driver that they talk about for emissions growth is population and GDP. So basically how many people we have, and then how much money, if you will, and our ability, if you will, to buy fossil fuels and to have energy are the things that drive the emissions growth. And so the models basically show the impact of population growth and GDP under different scenarios. And what these models basically show is that unless population levels level off and GDP growth moderates or basically stops, that we're going to continue to have emissions growth. And so basically, human influence will continue to grow in any scenario short of ceasing all emissions, as he would say. And he goes on to say that when he was in the private sector, this was a problem, this was a challenge. When he was in the government, it was an opportunity. And now he says, as an academic, he calls this situation a practical impossibility. In other words, we're not going to stop population growth and GDP growth. That's what he would suggest. Okay, I'm not going to spend too much time on this, but what I'll tell you is there are like 13 chapters. And so there are these graphs throughout the book, and I can't possibly show them all to you in the hour period. And so I had to cut a few out, and we can come back and look at a few more if you have more time. But he talks about the models, basically, how do you model the Earth from a climate perspective? And so they basically are modeling the Earth as 60-mile square grids with many vertical segments. And the ocean is modeled in smaller 6-mile grids with more vertical layers. And so there are more than 1 million boxes on Earth and 100 million boxes in the ocean. And as he points out, the phenomena is the climate phenomena, is sometimes smaller than these box sizes. And so assumptions had to be made. And the bottom line in the second graph over there is that the models don't actually track the observed temperature very well. And so it's uncommon for the popular media to discuss how problematic the models are. And the National Academy of Sciences in the United States noted the uncertainty of modeling of both climate change and the consequences of albedo modification make it impossible today to reliably, quantitatively make a statement on the relative risks, consequences, and benefits of albedo modification, which is basically geoengineering of the Earth system as a whole, let alone the benefits to a given region of the Earth. And so they're basically saying, we don't know enough to actually change the way we handle the climate. Okay, well, I've stuck one chart in here to talk about what everybody talked to me about when I first showed up, how hot it is. And so if I don't know whether it's really hot in South America. I actually saw pictures of snow in Argentina, but maybe I was wrong. But in any case, we've been hearing a lot about the hottest temperature in recent memory on Earth. And so this part of the talk basically says weather presenters have morphed into climate and weather presenters, blaming climate change for what are severe weather events. And so the typical headline is daily temperature records run rampant as the globe roasts. And that's certainly true this summer. And the US government's most recent assessment, 2017, was not only misleading, but wrong, as the author says. And it said, there are marked changes in temperature extremes across the contiguous US. The number of high temperature records set in the past 2 decades far exceeds the number of low temperature records. And so the author shows the graphs on the right. And so you can see what it's saying. Basically, the bottom chart basically shows the number of record high and record low temperatures recorded by year since 1895. And so you can note a distinct increase in the number of temperature records back in what in the US they call the Dust Bowl period. In other words, back in the late 20s and 30s were record high temperatures. And these number of record extremes are not being exceeded in the current period, which dates to 2020. And you can see at the top the temperature trends. And so the cold temperature trend is up. And so it's basically getting warmer at night. But you can see that the temperature trends on heat actually peaked in the 30s and 40s and have been kind of stable thereafter. And so he basically says some of the temperature change extremes, there are some temperature extremes. The actual number of high temperature records that show no significant trend over the past century, nor over the last 40 years. But the annual number of record cold nights has declined. So it's getting warmer at night. It's what you might draw out of that conclusion. Okay, well, here's some more fear, uncertainty, and doubt stuff for you. And so the one that they like to talk about is sea level rising. And so the cover of the 2013 National Geographic showed the water rising to the to the waist of the Statue of Liberty. And he goes on to point out in the chart at the bottom, okay, that at the Battery, which is at the tip of Manhattan, the sea level rise has been measured as 1 foot per century. It will take 20,000 years to reach the level of the picture. And so they're basically kind of doing FUD and lying with statistics by showing that picture. The media said a recent article on sea level rise in Oahu, Hawaii, had dramatic pictures of flooding over the past years and a map projecting areas that will be inundated with sea level rise of 30, 60, and 100 centimeters. And the author shows that the NOAA tide gauge records for Honolulu show 0.06 inches per year since 1905. And so it would take 200 years to reach 30 centimeter rise, the lowest of the examples in this press release. And so he says, we don't know how much rise of the global sea level is due to human cause and how much the product of long-term natural cycles. There's little doubt that by contributing to warming, we are contributing to sea level rise, but there's scant evidence that this will be significant or much less disastrous. Now he goes on to talk about natural climate change. And so he shows that it actually does change sea level, dramatically. And so in those 120-year cycles, he claims that the sea level dropped 400 feet at the minimum of the last glacial cycle, and of course it's going to rise back again as the Earth warms. And so they, as you can see in the second chart over there, the sea level has been rising over time, but it has been fairly stable over the last 10,000 years, as we showed earlier, as the temperature has stabilized. And so he points out that the peak of the last interglacial period was actually 20 feet higher than today. And so natural climate change could, in fact, increase the sea level, but the data we got doesn't seem to suggest that it's going to happen anytime soon. Okay, now he goes on to talk about 4 apocalypses that aren't global. And so here's the first one. A guy named Michael Greenstone of the Obama administration testified before Congress. He said the increase in global mortality rate due to climate change induced temperature changes by 2010 will be larger than the mortality rate due to all infectious diseases. We estimate the full mortality risk due to climate change to be an additional 85 deaths per 100,000. And so the author comes back and says, well, first of all, people don't die of climate. You remember, it's a 30-year average. And so what they die of is weather. And so it's things like drought and flood, storms, and extreme temperatures. And he plots the death rate since 1910. And so you can see the trends there. And so he basically shows that, in fact, they're declining. And the research paper that the guy at the top used, basically, they admit that the analysis is fraught with assumptions and that the numbers come under worst case temperature scenarios. In other words, if we assume mid-range scenario, then deaths drop. And so the lying with statistics part of that statement at the top is, just cherry pick the numbers, basically. Is there a question? Okay. Here's the second apocalypse. Basically, the New York Times says climate change threatens the world food supply. The United Nations warns climate change is hurting the availability of food because of decreased yields. If emissions of greenhouse gases continue, food costs will increase as well. And so he says the IPCC special report says data available since 1961 shows per capita supply of vegetable oils and meat to be more than doubled. And the food calories per capita has increased by about a third. The chart on the right demonstrates the increasing yields of wheat, corn, and rice. And so he says climate change induced yields of, or the report says climate change reduced yields of maize, wheat, and soybeans by 4.1, 1.8, and 4.5 respectively. And so the author says, in other words, although the yield increased by 100%, it could have gone up 104. And so again, by focusing on the wrong set of numbers, we basically have made it appear that climate change is a big problem. And then there's another talk on crops. And so the report says global crop and economic models project a median increase of 7.6% in cereal prices in 2050 due to climate change, leading to higher food prices and increased risk of insecurity and hunger. The author shows that a 7.6 increase is actually 0.25% over 30 years. Even the worst case scenario is only 0.75%. And the chart from another source shows grain prices actually dropping over the last 100 years. So he says, basically, if you want to lie with statistics, you talk about the increase per year, focusing on long periods because it sounds bigger. Okay, in the 2018, the fourth National Climate Assessment, it had a key message. It said, in absence of more significant mitigation efforts, climate change is projected to impose substantial damages to the U.S. economy, human health, and environment. Under these scenarios of high emissions and limited or no adoption, annual losses of some sectors will estimate to be in hundreds of billions of dollars by the end of the century. And so the news media, of course, followed with climate change will haul up the economy. The climate report warns of grim consequences. Climate change will cost billions. Climate reports warn of damaged environment and shrinking economy. And he basically looks at this chart on the right. And so what you'll note is that it shows the variation in the GDP as a function of climate change. But you'll note that 1.5 degrees is the limit set by the Paris Peace Agreement, or not Peace Agreement, the Paris Climate Agreement. But they're showing changes up to 15 degrees. And so it gives the impression that there's going to be huge changes in the GDP, whereas it's not nearly that big. We're basically dealing with stuff down at the low end of that chart. And so this is basically just exaggerates everything and to lie with statistics. And so what he points out is that it fails to put 4% change in GDP in context with the overall GDP change in 90 years. And so here's that chart. And so you'll see that climate change has little or no impact in global economy, even under worst case temperatures. Even 5 degrees C change only causes 4% GDP change through 2100. The GDP grows to $20 trillion, from 20 trillion to 80 trillion at 2% per year GDP growth. So $100 billion is minimal, in impact with those kind of GDP numbers. So this kind of thing lies with statistics by talking about the magnitude, but doesn't put it in comparison with the overall GDP. So that's the end of part one. I've skipped a whole bunch of charts to get here. But now the author is going to talk about the response. In other words, what should we do? And so you can see a chart on the right. It's basically the demand for energy increasing with developing countries. And so the US currently uses a lot of energy, but it's been pretty flat over the last number of years. And Australia, Germany, the developed countries are all the high users of energy. The developing countries such as India, China, Mexico, and Brazil are all basically not using as much energy and are expected to grow both in population and in energy use as they grow their GDP. And so he says to keep human influences below a level deemed prudent by the UN and governments, it requires CO2 emissions to vanish. By the latter half of the 21st century, emissions reductions would have to take place in the face of this growing demand driven by growth in population and development, the dominance of fossil fuels, and the drawbacks of current low emission technology. He says that the barriers combined with the uncertainties and vague nature of the future impacts of climate change mean that most likely the societal response is to adapt. And so that's basically what he's going to recommend. And so in this next chapter, he just talks about, the amount of carbon dioxide we're adding each year. And he says that 37 billion tons of carbon dioxide increases the concentration by 2 ppm. But if we even if we quit tomorrow, it says it'll take centuries for the concentration to drop. The chart on the right, you can see that the developed countries, the OECD countries, basically have been flat in their energy consumption over the last, the projected use from 2010 to 50 is essentially flat, but the developing countries in Asia particularly are going to increase their use. And so, there are 6.2 billion people are increasing because of their population growth and GDP growth. And so you can see another chart showing where the energy is going to come from over the next 50 years. And at least the US Information Agency says we're going to increase the amount of renewable energy, but we're not going to decrease any of the other sources. And so basically, he says, even with the current policies in place, the various scenarios, as you can see in the chart on the right, basically do not have the global emissions dropping to achieve the goal of limiting the temperature increase. And he says Europe, US, and Japan are generally meeting the agreement. Developing countries are not. And the conclusion is there's no way to legislate emission reductions on growing countries. So the world must adapt, is what he says. So here's the final part. He basically says it's really hard to eliminate carbon. And so he shows that the emissions have been flat since 1990 in this chart on the right. But our population has grown by 31% in the world. And so emissions have actually been reduced per capita. But he shows that even today, wood, oil, coal, and natural gas make up 85% of energy use. And so he goes on to say, what happens? Can you imagine no cars, gas-powered cars, trucks, buses, ships, or airplanes, no wood, coal, natural gas, oil, or used in electrical generation, no carbon from industrial production, including manufacturing, gas production, and plastics. Agriculture goes without fertilizer, electric tractors, and meat, no meat. No natural gas heat, boilers and heating, and it's not used in home and building, including existing housing, and no natural gas used to heat homes and buildings. Now imagine that this would happen simultaneously in all 50 countries of the world by 2050, which is kind of 20 years from now. And so because of the role of energy plays in our society, creating emissions is broadly disruptive of economies and behavior. And so he questions whether countries will invest the capital needed to transform their economies. And so he thinks it's unlikely that this is going to happen anytime soon. So the final part is Plan B. And so if you're not going to reduce your overall emissions, then what do you do? And so he talks about geoengineering and adaptation. And so, as you know, cloud seeding is an early form of geoengineering. So we're basically kind of forcing the earth to drop water in certain places. And so he talks about two types of geoengineering. There's solar radiation management and carbon dioxide removal. And so SRM basically changes that earth albedo through aerosol cooling, white roofs, or plants with more reflectivity, or even giant mirrors, as he says. And so people are basically talking about throwing dust and various stuff in the upper atmosphere to try to change the reflectivity of the earth, to try to reduce the gain of energy from the sun. The other approach is, of course, you use carbon dioxide removal to convert CO2 into a product. And so he points out that we'd only need to remove 10 gigatons. And he says today, the total demand for carbon dioxide on the earth is 0.2 gigatons, primarily in the form of fertilizer and oil production. And of course, it's used in things like soft drink bottling. I'm familiar with that. My family was in that business. In any case, another form of carbon dioxide removal, of course, is just to grow more plants on the earth. And so he basically summarizes the adaptation approach as being lots of incremental effect, changes. And so it's things like going to LED lights, using renewable energy. We're improving the efficiency of vehicles by using more electric cars and making them more efficient. Going to low carbon fuels. I think we're starting to do that for airplanes. And so he just talks about these other techniques. So basically, this is the end of the book. He says, climate is changing, but humans are playing a role, yet our global energy needs are growing. And so he basically says, hey, you might as well get used to it. It's not going to change. He is dismayed by the willingness of climate scientists, abetted by the media and politicians, to misrepresent what the science says. And so he would argue that what he just told you is that they are basically not communicating the science properly, and that many scientists are basically complicit by not pointing this out. Now, he's on the other hand, he basically wants to continue to observe the system so we understand and can model it. He wants to reduce the hysteria in journalism. He wants to pursue easy emission reductions like methane leaks in oil pipelines and production and reductions of CFCs. He would continue the efficiency in vehicles, and he would develop small nuclear reactors, improve solar and nuclear fusion. But he's not too bullish on this forced and urgent decarbonization by increasing carbon pricing and regulation, basically requiring it. He favors adaptation techniques with a backup of geoengineering. So that was his thoughts. What I'm going to do is jump to the last two slides, and then we'll come back and we can talk a little bit and see if I can need to show you a few more slides. So this is kind of the stuff that I pulled out of the slide. So I'm going to do my final brief aside on climate change. And so I basically say, is climate change a conspiracy? And I like to say that I've been looking at this since 1970. I got out of college in 1971, and so back in that time frame, organizations like the Club of Rome, who published that book on the right, have been promoting the theory that human population and development would lead to our demise due to nuclear war, pollution, disease, and extinction of the species, including our own. So read that book, Limits of Growth. You'll note that the focus of that book is all on population and growth, not on climate change. It wasn't even a thing in 1970. And so, but this was the start of the environmental movement, and the first Earth Day basically occurred in about that time frame. And what's interesting is, you know, you just saw probably on TV the head of the UN saying that the world was going to come to end in about a few years. Well, here's what the Secretary General said in 1969, which was the opening statement of Limits of Growth. You know, he basically said, I don't wish to be over dramatic, but if we don't get our act together in the next 10 years, we're going to die. Basically is what he said in 69. And so the UN is basically saying this, the same thing for over, I guess it's, what is that, 60, 70 years going on. And so we keep hearing that the world's going to come to an end in 10 years, and lately it's been 2 years. And so the question is, are they credible? Also note that the UN focus is on basically a global government that would prevent nuclear war, improve the environment, and stop population growth. And they don't really talk about it much, but growth in general. And so I would argue that suggests basically living in our past state, going back to an earlier state of our world. So in 1970, the existential crisis was overpopulation and running out of resources. It wasn't about climate. So what I do is I point out that this whole climate change occurred in 1979. And so you remember those Jasons, the academics that Stephen Kooning had led at one time, were asked to review CO2 on climate in 1978. And they then led to a National Academy of Sciences review of the effects of carbon dioxide doubling in 1979. And that's known as the Charney Report. And so this is where climate change came from. And I show that cover over there on the right. You can get a copy of that online. That's where I got it. But it basically says, it talks about doubling carbon dioxide would increase the temperature by 3 degrees plus or minus 1.5. And they go on to say that they didn't see any problems with the models, although they observe that that the ocean is a big thing, and it may delay the warming by several decades. And so that's their take. But please understand that what they were asked to look at was the effects of doubling the carbon dioxide. It didn't talk about the source or whether natural climate change was the cause. Anyways, I'm going to get off of this and let's chat for a minute. And then if you'd like, I can come back and show you a few more charts. So any questions?
Well, I would like to make some comments, David. Well, your talk actually emphasizes, as what a U.S. president said, that the only thing we have to fear is fear itself. So after after so many years of fearing with the greenhouse effect and some other very fearing data, which now we see that they are closer to pseudoscience than real science. My question is, being or having some serious institution involved with this, with this type of information, like United Nations, some governments, and what's your idea? What's behind this thing? Is political reasons, financial reason, religious reason, for this this information, well, this data, this confusing data, related to global change?
Yeah, so you're saying, why would the UN or the governments, what's their motive for
Right.
essentially trying to convince us to eliminate fossil fuel? And, I mean, that seems to be the heart of the climate change argument. I don't know. I mean, when I look at what I said in the last couple of slides, I suggest that climate change is just a front for the real concern, which is population growth and GDP growth. In other words, they would like to slow that down. I'm the first to say that if you go back and look at the model in the limits of growth, the population model is pretty much tracked. Okay, in other words, we've grown from a couple billion people, or I don't know how many people we had in 1970, but we've grown by 4 or 5 billion people in the world.
Right.
And so the Malthus theory, says we're going to run out of food or resources. And so that hasn't happened. Basically, the lack of resource problem has not happened. And so what I perceive is the environmentalists then go, say you cheated. What I see happening is they said, oh, how did you grow the food supply so that we didn't starve? Oh, you use fertilizer. You use more land. You killed animals by taking, eliminating their ecosystem. And so that's the cheating part. And that could be true. I mean, we're doing it. But anyways, that's just my thought, is that the real issue is population and growth. And that's shown in the data that, those scenarios. The only reason that we can stop it is have fewer people and not use as many resources. I have a hand up from somebody else.
Thank you, David.
Yep. I don't know your name, but somebody's got your hand up.
Yeah, David. I have a question about your presentation. I think, although it's beyond my imagination, but I was wondering, but finally, climate change is finally stochastic, it's a random process, or is a deterministic process, because due to the behavior of the human being, basically, after all.
Well, there's no doubt that humans have changed the earth.
Yeah.
I wouldn't argue with that at all. On the other hand, it's kind of presumptuous, I think, to say that humans control what happens with the earth. Things like continental shift, volcanoes, all these other things that happen with the earth. And then what appears to me to be clear, that we have astronomical effects like variations in the sun output, distance from the sun, the tilt of the earth. And then I would suggest that, this is me, I'm not a scientist, an astronomical scientist, but I kind of think we really don't know what's out there beyond Pluto. We learned that Pluto is not a planet. We think there's something else out there. And so this thing is basically rotating around the earth and on a strange cycle. And so you can see on that natural climate change plot, every 120 years, you got this major shift. And then you got all these little shifts. There's little ups and downs as it goes up and down. And so what I've read is that it's things like changes in the orbit or the alignment of Jupiter with the Earth. Mm-hmm. A big planet affects our gravity. And then what you've been seeing lately is the Gulf Stream is going to stop. And the other one that I know is that the Earth's polar north, in other words, the magnetic pole, is shifting. Yeah. And there are suggestions that every so often in geological history, it has shifted.
Yeah. Mm-hmm.
So, something like that could cause these drastic climate changes. And so I don't see that we have a whole lot of control of those. Now, so the question is our human emissions causing all of this. See, that's the problem I have. If they were saying that humans were causing a little bit on top of, see, the argument with this Keeling curve is natural climate change is going to happen. We're going to have sea level rise and the temperature rise. And oh, by the way, you've added some more on top of that. That's not what they're telling you. That's not what they're telling you. So that to me says it's political, but that's just me.
Okay, thank you.
Who's next? Yeah.
Yeah, I would like Dr. Bondurant, first of all, thank you very much for your very clear presentation. If I get it right, you are saying that the available facts actually do not support the thesis that the human activity is having a significant impact on the Earth climate. Yeah.
What I can do.
On the other hand, lack of evidence is not the same as evidence of lack. So the fact that all the facts together do not support that,
I'm cut off right at the moment.
Yeah, his image is frozen.
But to follow up on his question, what I would, I'm sitting in Colorado, and what I'll tell you is my house has been hit with large hail twice in the last 2 years. In other words, anomalous hail storms come in with baseball-size hail that have basically destroyed the roof of my house for 2 years apart. I had not had any hail damage to my house in the last 20 years. So, I mean, there's some anecdotal evidence that something is changing. And so, I'm not willing to say that things are not changing. So my only question is whether it's part of that natural climate change, or is it the humans that caused it? Next hand, I see another hand. But you're muted, I think. Fire away again.
My name is Federico Viramontes from Monterrey section. I enjoy your presentation very much. Thank you. In the meantime, just the switch from internal combustion engines to electrical automobiles is going to cost a lot. And I see that some of the reasons that they argue are not very clear. Like, where are all these materials required for the electrical vehicles come from?
Right.
Do you have some thoughts about what is happening right now?
Well, I'm an electrical engineer, and so I kind of like electric cars. On the other hand, I'm an engineer and I like to do a cost benefit analysis. And so I'm not too happy that they've driven the price of cars up. In other words, one of the things I do as a volunteer is, I've worked with homeless people in my town here. And what I see is that all these things that we're doing for the climate are driving the price of houses, the price of cars higher, and making it more and more difficult for particularly poorer people to afford those things. And that's kind of the message of this talk, is the developing world, of course, are the people that are going to want things like cars, gas, heat, electricity. And as the population grows, more and more people are going to want that. And so we're going to want more energy. And so the message, of course, is we don't want the developed world to have it. that's the way I would look at it. And what you hear from the UN is essentially, we would like to tax the poor, the wealthy countries to send things like solar cells to Africa. In other words, you know, we would prefer that you don't use coal or gas to do that. We'll just tax these other countries and send it over. And so I don't like this you know, approach to the forced change. Now, I just bought a new car about a year ago. I didn't buy an electric car. Now my son has one. He has a Tesla, and so it works great, no doubt. But it's a $50,000 car, and I decided I didn't want to buy a $60,000 car, and so I didn't do it yet. But clearly, the policies are such that, and see, the thing is, I live in a nice neighborhood. And so the benefits of these subsidies that governments are giving, they're primarily falling on the wealthy. In other words, they're buying, I like to say they're buying cars for doctors.
I see. I see.
You know,
Very interesting.
that's who bought the first cars, okay, because they could afford it. You know, I could afford one. I mean, I would buy one, except, and I believe that electric cars are going to be cheaper. You know, I mean, they're clearly simpler. So it's the battery, you know, it's all about the battery. And so I agree with you. We don't know where the resources are coming from yet. We don't know where the power is going to come from. We got to develop a new grid to power it. But I think it'll happen. So I'm not against it. I just, you know, it's the question is, do you have to force it, or do you just let it happen?
Thank you very much.
Yep. Joni.
Yes, hi. I want to know, what is your opinion about the declaration of the UN about the end of global warming and the beginning of the global boil?
Say the last part again. The beginning of?
The beginning of the global boil. The UN made that declaration this weekend.
Oh, that actually, I didn't hear that declaration, but and I still didn't quite hear the last part. Can somebody else help me understand what she said?
I have no idea.
Yeah, the United Nations Secretary a couple of days ago say that the warming area is ending. We are in the boiling area.
Oh, okay.
Yeah.
That sounds like fear, uncertainty, and doubt by my definition. But you know, that's, you know, they're just a very, what I would consider conscious propaganda program in the United States, at least, to say that it's the hottest ever. And so that gets back to that model. Okay, in other words, how much do you believe the model? Because I'm pretty sure, you know, there is no such thing as a global thermometer. It's got to be a model. And, you know, but, you know, my bigger issue is back to that natural climate change versus what's being said. In other words, I'm not a darn climate scientist, and so I can't. All I do is I look at that chart and I say, when somebody tells me that the carbon dioxide level is the highest ever, by comparing the proxy data to this other data, I would like to see some backup to say how they conclude that. Because what I would conclude is the 280 ppm captured in ice is not the same as an atmospheric measurement. And I'd like to see some data from somebody that tells me otherwise. In other words, you know, if 120,000 years ago, the temperature was warmer than it is today, the poles melted at 280 ppm, because that's what the ice cores say. Then, of course, you might worry about 400 being, you know, we might be boiling, okay, as the UN secretary says. but I think that they don't know. That, you know, that I don't draw that conclusion from that data personally.
Thank you.
Yeah. But the bigger thing is, you know, I'm sitting here at home, and, you know, they're talking about a heat wave in the central US, hottest ever. But I'm sitting here and it's been a very moderate summer with lots of rain, temperature. Now, 85 degrees is pretty warm, but it's not unusual for this time of year. And so I don't think you can draw that for the world. You can draw it for Texas and you can draw it for Phoenix, Arizona, which is, you know, normally, you know, I've been there when it's 114 degrees Fahrenheit every summer. So they go talk about Italy being hot in Europe, and I'm watching a tennis tournament. I'm a tennis player, by the way. So I'm watching the tennis tournament in Hamburg, Germany. Everybody in the stands has got a coat on, heavy coat, and a stocking cap because it's so cold. It's 59 degrees in Hamburg, Germany. At the same time, they're to say it's the hottest point in the world. So there's my problem. You know, it's back to the model. You know, it's not based upon anything other than a local data point that I can see.
Okay.
Well, thank you, David. It's almost 7:30 p.m. in Argentina, 3:30 or 4:30 in the other countries. I think thank you very much. Thank you, everybody, for listening. It's some food for thought, I think, for everybody.
Mhm.
Yeah. Did
You're
you
gonna stop
listen?
recording then? Yep.
Okay. I am going to stop recording.